Did you know that the coldest stuff on Earth is made not with refrigerators, but with lasers? The blue ball you see here is a cloud of strontium atoms, about 1,000th of a degree from absolute zero. This is part of a physics experiment at Stanford University, and in this video I'll explain how we use lasers to reach such cold temperatures. To begin, we need to understand some basic properties of atoms. The electrons of an atom form a cloud around the nucleus, but this cloud can only take certain specific shapes, some of which are shown here. The shapes are called states of the atom, and different states have different amounts of energy. If the cloud is close to the nucleus, the state has low energy, and if the cloud is far from the nucleus, it has high energy. An atom can transition from one state to another by absorbing or emitting a photon, or particle of light, with exactly the right frequency. The reason that the frequency has to be right is because, by conservation of energy, the energy of the photon has to equal the change in energy of the atom. The energy of a photon is just its frequency times a constant, Planck's constant. So the frequency has to be just right to conserve energy. The next thing we need to understand is the Doppler effect. You may have experienced this while driving past a siren on the highway. When you are moving towards the siren, the frequency you hear is higher than if you were standing still, because you're passing through the sound waves more quickly. If you're moving away from the siren, the frequency you hear is lower. The same thing applies to atoms. If an atom is moving towards a laser beam, it sees the photons of that laser as having higher frequency than if the atom were standing still. So the trick to cool atoms is to simply shine two lasers from opposite directions, whose frequency is just slightly lower than what the atom will absorb. If the atom is moving towards one of the lasers, because of the Doppler effect, it will start to absorb photons from that laser. Since photons carry momentum, each photon absorbed will give the atom a little push in the opposite direction, slowing it down. If you do this along all three directions, up, down, left, right, and forward, backward, then no matter which way the atom is moving, it will get slowed down by the lasers. Temperature is just the random motion of atoms, so by slowing them down, we cool them. We can use this trick to get them as cold as 1/1,000,000th of a degree from absolute zero. I hope you found this explanation useful. If you want to learn more, the term to look up is Doppler cooling. Or if you have specific questions, hit me up in the comments.